Well, let us discuss the electromagnetic spectrum. The spectrum means it is a series of wavelength, the all possible wavelength together. In the present discussions, we will have the spectrum for in 7 categories. We will discuss today together. That is starting from gamma rays, X-ray, ultraviolet ray, visible ray, then infrared, microwave and radio waves. We will classify the all possible spectrum, the frequencies of electromagnetic waves into these categories, 7 categories, and accordingly we will discuss the frequency, wavelength, the production applications of day-to-day applications of these electromagnetic waves. Now to start with the gamma rays, if you see to the table, here gamma rays correspond to a wavelength range of 10 to the power minus 14 to 10 to the power minus 10 meter, and such rays, gamma rays, generally produced in nuclear reactions and in emission of radioactive particles or radioactive nucleus. The gamma rays is produced, and the applications of these gamma rays are mostly in research areas and in cancer treatment, because the gamma ray is able to destroy the cancer cells, so therefore it is mostly used also in cancer treatment. Now next to it is your X-ray. X-ray, if you see to the wavelength range starting from 10 to the power minus 13 to 10 to the power minus 8 meter, and such X-ray can be produced by bombardment of high energy electron on metal targets. The metal may be of sodium or potassium kind of metal, and these applications of X-ray is mostly in cancer treatment and also in diagnosis of bones and fractures. And next to that X-ray we can have ultraviolet wave, which correspond to 10 to the power minus 10 to 10 to the power minus 7 meter, the wavelength range. And ultraviolet, it is mostly our sun carries the ultraviolet component of the rays. Besides that, some very special kind of lamps for producing ultraviolet rays are also there. Very extremely hot bodies, like the case of your welding, they also emit your ultraviolet radiations, and applications of these ultraviolet radiations in the field of designing of goggles for the welders, so as to protect their eyes from the ultraviolet radiations during welding, and also in designing of glass windows. Those are in polar regions, so as to filter out the ultraviolet components present in the sun inside that of the residential area. And one of the most latest applications of this ultraviolet radiation is in LASIK, that is the laser assisted in situ keratomycosis, which is a very advanced eye surgery that is also used using the ultraviolet radiations. And next is visible radiations. In visible radiation, it is mostly used for visual purpose, and the wavelength range is 400 to 700 nanometer, and I have mentioned it in the table as 4 into 10 to the power minus 7 to 7 into 10 to the power minus 7 meter. The production of such visible light can be by our filaments present, and the tungsten filament, you can say, in ordinary bulb, electric bulb, in CFL, in LED, like that we can produce these lights, visible lights. And infrared, if you see to the infrared radiations, its wavelength range correspond to 10 to the power minus 6 to 10 to the power minus 3 meter, and infrared is produced generally by thermal motion of water contained carbon dioxide and ammonium type of molecules when heated up, or similarly some heated particles when they move, they also radiate this kind of infrared radiations. And infrared radiations is mostly used for maintaining the average temperature of the earth. In greenhouse effect also we use the concept of retaining the sun's temperatures. That means when we develop certain kind of crops, we covered it with selected glass material so as to allow the sunlight and not to go out. In that case also we develop the concept of greenhouse effect so that the warmth can be maintained inside the glass house, and such cultivations are mostly practiced in polar regions where the environment temperature is very less. And it is this infrared radiation is also used extensively in physical therapy. It is also originally used in our remote switches, which we use frequently in our homes. The infrared is also used in your satellite for detecting the satellites which are used in military cases. And now the microwave, which is an important part of the electromagnetic spectrum, correspond to wavelength of 10 to the power minus 3 to 10 to the power minus 1 meter. And this microwave is mostly produced by vacuum diodes like klystron, magnetron, GOM diodes. The discussion of such electronic devices will be done in subsequent classes. And your domestic applications of this microwave are mostly seen, that is woven. You know, the water particle is made to vibrate at a frequency of 2.45 gigahertz, and this vibration of this water particle present inside the food items, that is the basic of cooking of the materials. We do not supply the temperature directly to the utensils or to the food particles, rather these frequencies, they vibrate the water particles present inside the food materials, and the cooking is possible. Also, this microwave is frequently used in our aviation industries, where we allow these frequencies allowed for navigation radar detectings in our aviation centers, that is mostly during aircraft transitions. Then the last one is your obviously group of radio waves. Now this group of radio waves, if you see, it starts from a very low of 3 kilohertz to 300 gigahertz. Such a very large range for radio and TV communication, it is mostly used. And the radio wave is produced by oscillators, which will be discussed in our subsequent classes, and it can also be produced by accelerated motions of charges in conducting wires. And if you see the radio waves, it consists of a low frequency radio wave up to the cell frequency, the frequency we are using in our cell phone. So in the cell phone you use ultra high frequencies, which corresponds to a wavelength of 10 to the power minus 1 to 1 meter, the wavelength. And FM, the frequency modulated wave, which is very popular, it is allowed for a frequency, for a frequency range of 88, that is 88 to 108 megahertz. This is the allowed region for FM. Similarly, the allowed region for television is 54 to 890 megahertz. That is the allowed for televisions. Beyond that, you cannot send such other frequencies in for television communications. Then the shortwave range is allowed for 1710 kilohertz to 54 megahertz. This is also allowed for shortwave communications in mostly very research institutions. They use the shortwave frequencies. And for amplitude modulation kind of wave, you are allowed with 530 to 1710 kilohertz frequency range. And besides that, 30 to 300 kilohertz, which is of low frequency radio waves, is allowed for hands and all that kind of popular localized communications. So this is all about the electromagnetic spectrum, having classified into 7 categories so far as their use and productions is concerned. And one important thing you must mark here, that I have tried to express all their range in meter units. It is because the conversions of such units also are given in a tabular forms here in centimeter, millimeter, micrometer, nanometer, angstrom, Fermi and kilometer. All I have converted into meters. And similarly, the kilohertz, megahertz and gigahertz to hertz. Such a standard conversion I have made, it is to facilitate in memorizing these entire informations, and that will help you in answering the questions coming in examinations. For example, if a question is asked, the electromagnetic wave of wavelength corresponding to 1500 nanometer lies in which region of spectrum? So naturally, The answer will be infrared region. It is because the wavelength asked is 1500 nanometers. So you can convert the 1500 nanometer equal to 1500 into 10 to the power minus 9 meter. So that will come to equal to 1.5 into 10 to the power minus 6 meter, which falls in the infrared regions. This is how you can answer easily by following such a standard unit in remembering the data. We'll see the more about these electromagnetic waves and some problems in our subsequent classes. Thank you.